Okay, chapter 4, we're going to get into graphing trig functions. The way I'm going to try to break it up is it talks about graphing all 6 trig functions. I'm going to kind of get this broken up into 2 videos or 2 days. Day number 1 is going to be graphing the sine, cosine, tangent ones, and I'll deal with the reciprocal ones after that. But first, just to kind of start it off, evaluating for angles that are in the first quadrant when you're given sine, inverse sine of, or inverse tangent rather, of 4/3. The idea is that we will be in quadrant 1, and since tangent is y over x, I know that the y value in this triangle is going to be 4, and the other x value of this triangle is going to be 3. I can use Pythagorean theorem or a Pythagorean triple to get a radius of 5. So when I go to find the sine of that particular angle, excuse me, I'll take the opposite over the hypotenuse, or the y over r, and get 4/5. Okay, same thing here, except for we're in the first quadrant. Now it's cosine, so now that 29 is now the radius, because cosine is x over r, and the x value would be 21, and I would do Pythagorean theorem to solve for y. I've done this before, so y ends up being 20. So if I go back to find tangent, okay, the tangent is going to be y over x, so now 20 over 21. Okay, now onto the graphing rather. This is going to be periodic functions. A function is a function returning to its same value over a regular interval. The period is going to be a time it takes between those two values. So like here, the one in blue starts at 0, goes up to 1, back to 0, down to -1, back to 0. That's 1 period. It happened between 0 to 2 pi. The one in red starts at 1, 0, goes down to -1, 0, and then stops at 1 again in 2 pi. What are these? Well, they're actually the values of sine and cosine. Are sine and cosine periodic? Yes. They typically have a period of 2 pi unless we manipulate some values within that function. Starting off with sine. So if you recall, in triangle trigonometry, sine is defined by y over r. If I go and I look off of the unit circle, the radius now becomes 1, so I can just look at the y values. So in graphing sine, what I'm going to do is I'm going to look over at this unit circle, and I'm only going to be interested in the y values of this, or all these ordered pair. Okay, now this is going to be a little bit of overkill. I'm not going to plot all these points, but just to kind of show you where they are, I'll put them in the table and go from there. But like I got 0, 1/2, the square root of 2 over 2. Sorry, I missed a couple spots, excuse me. Square root of 2 over 2, 1, negative square root of 2 over 2, positive square root of 2 over 2, 0. Now I'm finding these negative square roots of 2 over 2, -1, negative square roots of 2 over 2, and finally back up to 0. So when I go through and I graph this, well, basically what I did is I went 1 full circle, and that's going to give me 1 full period of my graph. Truthfully, when I graph this, what I do is I just grab these values for sine, and that's good enough. And my period is going to end up being 2 pi. Now, that can also happen in the negative direction. So I can extend that graph over in this. So they go on forever. I'm butchering my graph, but you get the idea. Like about, there we go. Okay. Now, when it comes to cosine, really very, 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 very similar concept, except for now cosine, remember, is x over r. So if I go with this circle and I put in r is equal to 1, I can just look at the x values. So I'll go to all my ordered pairs and I'll look at just the x's. Okay, again, this is going to be overkill. I'm not going to plug that many points. In fact, like I said, I usually just use 0, pi over 4, or 2, pi, 3 pi over 2, and 2. And that should be enough to say, hey, I start at 1, crash down to 0, get to -1, 0, and then back up to 1. So it looks like that graph in red. Or again, I've got my full period in 2 pi because it took me 1 full circle to get that pattern. And I can get the same thing going backwards. I'm pretty confident that sine and cosine should find you in a way that you're pretty comfortable with that. It is barely, oh, here we go, that's a typo, forgot, I missed that one. Cosine of x. Tangent, on the other hand, that's the one where I think it's going to take a little bit of time to get used to. Okay. So now tangent, remember, is y over x. So I'm going to go to each of my ordered pairs, and I'm going to make a fraction of 0 over 1, which is 0. 1 over 0, which is undefined, because I can't divide by 0. 0 over -1, which gives me 0. -1 over 0, which is undefined. And I'm going to go to 0 degrees. I'm going to go 0. I'm going to get to pi over 2. I'm going to put UND, undefined. Back to 0, pi over 2, undefined. Now, at undefined, since it doesn't exist, so like pi over 2. So here's pi over 2. I'm going to put a dashed line in there as an asymptote. So it's going to come really close to touching, but not quite. Okay, and then if I go over to 3 pi over 2, which would be about right here, I'm going to put another asymptote. Okay, notice that the distance between these two is not a full 2 pi. It's actually pi, because I'm really only going to worry about tangent existing from one undefined to another undefined. So really, tangent only happens every half circle. Now, I'm going to stick with pi over 4 because I know the tangent to pi over 4 is 1. Okay. 135 is -1. Okay. And how am I getting that? Pi over 2, I'll go 1, -1, and I got undefined. So it kind of looks like, like this. What did I say? Pi was 0. 3 pi over 2, or 4, and 5 pi over 4. Okay. If I go up to 1, and go down to -1, it kind of looks like this. And if I use pi over 4, I'll be at 1. Well, 0 is also going to be 0. I'm actually going to go over with negative pi over 2, and I'm going to get another -1. And I'm actually, let's see, pi over 4 rather. I'm going to go over to negative pi over 2, and I'm going to put another asymptote. And I'm going to go another pi, I put another asymptote. And this graph of tangent is just going to kind of loop up and through from -1, 0 to 1. So I hope tangent is not freaking out too much. We'll talk about it a little bit more in class. But yeah, sine and cosine tangent, and we'll worry about the reciprocal functions the next video.